in your notes, if I didn't tell you the order that you should be writing is dilation, reflection, translation, is because of BODMAS. Therefore, there's an acronym. We call it Dr. T. That is important when you do your exams. When the question asks us to find the sequence of transformation, that's exercise 3E, then the sequence follows what you see here. So the order, when you write it, it would be the multiplication first of the y coordinates. What are we doing? We're timesing it before we add. We times by -1 before we -1. So when you write your sequence of transformations, it should be in the order of Dr. T. Okay, so there's a multiplication component before the add, subtract. And that's simply because of BODMAS. Okay, it's the order of operations. So write Dr. T if you didn't know. So when you're doing your sequence of transformation, I'll show you a variety, what might look like in the exams as we go through this week. But that's the order you should be sticking to. Okay? All right. Let's now do some examples. So this is probably going to link more to exercise 3D. How to convert this equation to a transformation equation. Now, I keep the layout the same for each one so you can see the changes as you go. If you learn this and you understand it, then that's pretty much 3D. So you can skip 3ABC and just get right to D and work on that skill. And then 3E is just working backwards. Okay, so those are the two main exercises of chapter 3 if you haven't seen it. Okay, here we go. So let's have a look at this. So it says determine the rule of the image, which just means what's the new equation, when the graph of y equals root x. So I've got a root x function, and I want to dilate it by a factor 2 from the y-axis. So remember, y-axis is the vertical line. From, just use your hands. You're moving away from the y-axis. So it's a horizontal stretch. Okay, so this means horizontal stretch. So you're timesing all the x's by a factor of 2. So it means you double all the x coordinates. And then reflected in the x-axis. So the x-axis reflected means that you flip over the x-axis. So it's a vertical flip. So this is a vertical flip. So to flip vertically, it has to affect the y value. So this is clearly a negative on the y. And then translated by 3 units in the positive direction of the x-axis. Big lengthy sentence. All it means is move to the right by 3. So your job in the first skill is to rewrite. So if your x, y coordinates are the original, I want that transformation. And that's the skill, being able to rewrite the sequence here. So here, let's rewrite it. Horizontal stretch means I have to affect the x coordinates because I'm moving my hands. As you can see, I'm stretching it out away from the y-axis. So that means it's 2 times x. So I double all the x coordinates for a horizontal stretch. I need a vertical flip, which I know needs to be a negative y. Okay, so a negative vertical flip means from the y positive to the y negative. That's a vertical flip. So reflected the x-axis, and then translated by 3 units in the positive direction means go to the right by 3. Okay, so that's my sequence map. That's mapping notation, first skill, learn how to read. Now, the technique you learn in exercise 3D is, well, how do you rewrite the new equation? Now, in the textbook, and the way we normally teach it is we say this is the original, I'll call it OGX, and then OGY. Okay, so original X, original Y. The new transformation, after you do 2 times the X and then plus the 3, you will get a new X coordinate, which we use a dash to remind ourselves that's the new X. This is the new Y coordinate after you flip it. Okay, so whatever the original Y was, you flip it, that's your new Y. Whatever your original X is, double it and then add 3, that's your new X coordinate. Why am I putting dashes on them? Is because as you're doing this technique I'm showing you, it's easy to determine which one's the original and which one's the new. Okay? So from here, we get 2 equations. We now have, to get the new X coordinate, it is the result of doing double the original X, add 3. To get the new Y coordinate, it is flip the original Y. Okay? Now I've got 2 set of equations. So this is equation 1, equation 2. The goal is to replace this. This is the original function. Right? So if you want to get the new equation, you need to replace the old Y and the old X. to replace the old y, well, what does the original OG y equal to? To replace the original x, well, what is the original x equal to? Now, since we've got this set up, I can solve for original x and I can solve for original y. So here, I rearrange the equation. I say, all right, well, minus 3 on both sides. 3 take away 3 cancels out. I get new x, take away 3, will equal to double of the original x. Divide both sides by 2, and I get x dash minus 3 on 2. I'm just going to divide this by 2, divide this by 2. And what this means is original x, so OGX, is the result of taking the new x, take away 3, and then divide by 2. Same thing with this one. If I then followed the same method I'm showing you here, I need to find OGY. So OGY is, I need to divide both sides by negative. So divide by -1, divided by -1. And you can see that I now have negative y dash is equal to OGY. Why do we do that? Well, now I can replace the original y and original x. I can then say, well, original y is equal to this. And original x is inside the square root. So if you replace that, resubstitute it. So if I sub original y equals to negative y dash and original x, which is x dash minus 3 on 2, what I will get is this new equation. Negative y dash is equal to the square root of x dash minus 3 on 2. What we normally do is we rewrite it as y as a subject. So I need to divide both sides by negative, and then this is what you get. Y dash is equal to negative of the square root x dash minus 3 on 2. Now normally in the exam you don't leave your answers with the dashes. That means your transformed equation, the new equation, is y is equal to negative of x minus 3 on 2. And what you find is that to convert this graph to that graph, that follows the sequence of transformation you wanted. It means you're going to do a horizontal stretch, you're going to flip it, and you're going to move it to the right. So I'm going to do it on Desmos so you can see that that transformation that you wanted, by replacing the function, that's what you're going to get. Over time, as you do this, especially year 12, you need to be able to be at a point where I give you this equation and you can read that from this. So when I see that, I already see dilation factor 2, and I can work that out, and I know that's going to be moving to the right by 3. That's a horizontal flip. Oh, sorry, vertical flip. Okay, so you will be at a point after you do a couple, you should be able to read the transformation equation and determine the sequence of transformations. Okay, that's exercise 3E. So 3E will give you this, and you need to work backwards to get here. 3D goes from what we just did, moves forward to get here. Those are 2 skills from chapter 3 that you need to learn. Yeah.
When you're doing that, can't you just like save time and convert by negative and you get a y and an x and a
That's right. That's essentially what you do. And that's one of the techniques I'll show you later. Yeah. All right, let's have a look. Let's look at Desmos and let's visualize this. Where's Desmos? Where did I put it? Was it over here? Yeah. Let's have a look at Desmos. So first one was root of x. Here's your original. This is OG function, right? Then the new one, we said the new one should be y equals negative root of x minus 3 on 2. Can you see, if I do it in parts, I'll do it as slowly. So y equals root, where's that dash there? Root, let's do x on 2 first. Can you see how the dilation when it's on 2, it's actually being stretched? Can you see it? I'm just pulling all the x coordinates. This one would shift across by a factor of 2. Each one is being multiplied by 2. I'm doing a horizontal stretch. That's why it gets thinner along the x-axis. Yeah, so the larger the number, more it will stretch further out. Okay, so that's what the x on 2. Then when I put in that minus 3, can you see how it shifts to the right? Which is what we wanted before. The question says 3 units in the positive direction of x-axis. It has. So not only has it moved to the right, it also has that horizontal stretch that we want, factor of 2. And then the last one we wanted was there need to be a vertical flip. There we go. I put a negative there, and that's the exact equation that we came up with that describes the sequence of transformation we wanted. Okay, so that's the skill. So the first one was mapping notation. Then I taught you a method to replace OGY, OGX to get the new equation. That's the skill you do in 3D. Cool? So 3A, B, and C, you can skip that. The reason why is because A is just translations, B is dilations only, and then C is reflections only. But you might as well do D because it combines them all, which we just did. So what I just showed you was an example of exercise 3D. You can cut your work by just doing 3D. Does that make sense? Yeah? All right. Let's do an example. Now let's go back to your sheet. Let's do an example where you're going backwards now. So this is now going backwards. They say determine the sequence of transformation where you went from the original graph to the new equation. So I've given you a new equation, and over time, you should be able to read this and determine the sequence of transformation. But if you don't know how to do that yet, by working backwards, this technique I'm going to show you, that'll allow you to read the transformation. You'll start to see the patterns. Okay, so here we go. So the first skill is, this is original. Find the word from. So they always say moving from this graph to the next graph. So this is OGX and OGY. OGY. OGX. This is your new X. That's your new Y. Okay? So if you write it that way, so I'll just put the dashes to help you move backwards. When we're going backwards now, so we're going to go backwards until we get to that point again. This is how it works. You had to replace the original Y, right? So that means this Y at the moment, let me just fix that. You have to replace the original X. So inside the square root, you're replacing that. What did you replace it with? This is what you replaced it with. So that means I can say, therefore, X dash is equal to, X dash minus 2 is equal to X. You see what I'm doing? So I'm just looking at the original function. Doesn't matter about the square root. They both have to have the square root. It's what I'm replacing the X. Original X is being replaced with X dash minus 2. So I say original X must equal to then new X minus 2. That's one equation. What about the plus 1 and the divide 4, times 4? Well, that plus 1 and 4 doesn't belong with the X. It has to belong with the Y. So now you rearrange it. You rearrange it so it goes onto the Y side. So here I say minus 1, minus 1. That gives me now Y dash minus 1. That cancels out. And Y dash minus 1 is equal to 4 roots of X minus 2. And I need to get rid of that 4. Divide both sides by 4. This must be the transformation involving the Y coordinates. So now I pull it back up. I zoom up and say, that means original Y must have been replaced. This must have been replaced by Y dash minus 1 on 4. Can you see what I'm doing there? So I'm working backwards. Before we sub something in here to get here. We sub something in here to get here. And we rearranged it to get that answer. So now working backwards, I just needed to figure out what goes with Y's and what goes with the X. And that's what I wrote. Now from here you can work backwards. So from here you can solve it. You can say, all right, well, if original X equals X dash minus 2, your goal is to find what is new X, what is new Y. So you're solving for it now. So here's your two equations. You have Y equals Y dash minus 1 on 4. That's equation 1. In equation 2, you have original X equals X dash minus 2. So rearrange it to find X dash and Y dash. Here we go. Add 2 on both sides. X dash is equal to original X plus 2. That is my first one for X dash. Then you do the same for this one. Times 4 on both sides. Because it's opposite of divide 4. 4 divided by 4 cancels out. 4y equals to y dash minus 1. Add 1 on both sides. And you get 4 times original y plus 1 equals to y dash. And there we go. What have we done? We figured out now y dash to get new y is the result of timesing 4 to the original y plus 1. And to get the new x, take the original x plus 2. So if I fill it in, original x plus 2, and this is 4y plus 1, you can read the transformation now. This is what we did last session. So from here, dilations come first. Remember Dr. T, if you answer this in the exam, let's do it. Dr. T, do I have a dilation? Okay, how would you write it? So in an exam, if they ask for sequence transformation, how would you write the sentence? Because they expect a sentence here. Who wants to have a go? Hands up. Noah.
Dilation of factor 4 from the x-axis.
Very good. That's it. Because that 4 is times in the y coordinate. So y coordinate, move your hands. It's moving away from the x-axis. It's a vertical stretch. So you would say dilation of factor 4, because it's timesing by 4, from, and this is the key part, from the x-axis, because you're affecting your y coordinates. There are no more dilations. Are there any reflections? No. So Dr. T doesn't work there, so it's dt. There's clearly a translation, and at this point, like I said, you can write it in the proper way, or you can write it, now they accept, you can write right up or down, whatever it is. So in this case, what do we have? Hands up. Who knows? Lucky?
I did this right at the start. It was translation of plus 2 in the x-axis.
Yep.
And translation of plus 1 in the y.
Very good. So it means right by 2 and up by 1. Okay, so Lucky read the proper writing for it. If you have space and you have time, do it. Otherwise, you can write right by 2 and up by 1, and that'll be fine as well. Okay? So you can say translation of 2 units right and 1 unit up. And over time, you'll be able to read it, because after you do it for a while, you realize that 4 and the 1 is always going to be affecting the y coordinate. So the plus 1 will, when I see that, I know straight away up 1. The 4 is going to times to the y coordinate, because once you pull it on this side, you pull it back up, it's still 4y. See that 4 and the plus 1? There's a commonality there. So the y's are actually the easiest ones to read. When you first look at an equation, I say up 1, dilation of factor 4 from the x-axis, and then here is the only one I got to be careful of. Anything to do with the x is actually the reverse. Okay, so if it's minus 2, you end up finding that when you go through the process, it ends up being plus 2. That's why before, notice when it was x on 2, I knew when it was divided by 2, I know the answer has to be dilation of factor 2. It's the reciprocal. Okay, and that's what it ends up being. So times it by 2 ends up being a half. If you write a 2 here, then that will be a factor of half here. So x is the only one that is tricky, but over time, you can then just look at an equation and read the transformation without doing what I just showed you. Okay, that's 3e. So pretty much in this session and last session, you've learned 3a, b, c, d, e. And that is the essence of it. GH, F, G, H is sketching. So doing what I just did on Desmos, you have to do that without a CAS calculator. You have to know how to take root x, knowing the original function. If you know how to move it to the right, you know how to flip it, you know how to stretch it. That's all you do from F, G, H, I's notation. So the next session, I'll do some sketching, and then I'll do some notation with you, and you're pretty much done with chapter 3. So the essence of chapter 3 is 3D and 3E. That's what you want to learn. Okay, and then over time, you shouldn't be using the techniques I'm showing you. You should be able to do it by looking at the equation. That's the goal. Okay. All right, team, I'm going to stop the video there.